Hello, morning everyone, and welcome to today's broadcast. Today's broadcast, it's because it's what it says it's on the OBS screen. Welcome to today's continuation with answering every question in the book. This is part 11, and we are looking at topics starting at topics 54. Okay, so let's go straight to the business. Here we are. So what we've got here is we've got topic 54, plot coordinates on a coordinate grid. Okay, so mark the point 2, 3 on the coordinate grid. Okay, so there we go. 2, 3 is, so the x coordinate is first, so that's the one on this line, and then it's the y. So 2, 3, 2, 3, so that's going to go there. 2 is mark the point -4, 5 on the coordinate grid. So -4, 5. I mean, the numbers are very small for this, but I think it's fine because they're just there to kind of let you know that each square is 1. 0 minus 2, so 0 is the center line, -2 is here. Mark the point -3, -4 on the coordinate. Oh, I've spotted something. Okay, right, on the coordinate grid. We missed out the word grid. So let's find this. That's going to be back this way. Here we go. Here's all these grids. Right, on the coordinate grid. Right, perfect. Right, here we go. -3, -4. So -3 here, down to -4 there. And then we've got these questions as well. Might as well get them all done in one go. Mark the point 6, 1 on the coordinate grid. 6, 1. Here we go. Mark the point -1, 0 on the coordinate grid. So that's here. Mark the point 4, -3 on the coordinate grid. 4, -3. Mark the point -2, 2 on the coordinate grid. So that should be here. Okay, right, well, there's scenario questions. So let's get these ones marked. So here we go. I'll move that to the side. Oh, screen share is connecting. Please continue to work. I was like, are you okay when we're large? You're okay when we're large? Right, let's just do this. Okay, let's not risk anything. Right, so here we go. Right. Oh, these are very small answers. Okay, so here we go. Yeah, that matches here. Yeah, that one's the same as well. Yeah, and here, excellent. Okay, next ones. Oh no. Oh, they're over here. Okay, so 5. Yeah, we're looking good. 6, lovely. This was a very nice first activity to start the day. Yeah. And here we go. Perfect, right, let's go on to the scenario questions. Okay. Now, let's see what happens. Okay, here we go. Right, scenario. Oh, okay. These are a bit different. Okay, so given the points A, 2, 4, B, 6, 4, and C, 2, 1. Identify the fourth point that completes a rectangle. Okay, so the fourth point that will complete the rectangle will be here. Okay. It'll be here. So that is 6, 1. Is that clear that it's expected to give the coordinate? I don't know if it is. Let's have a think about that. Given the points D is negative 3, 4, E is 1, 4, and 4 is 1, 0, identify the fourth point that completes a square. Okay, so that's going to be here. So that is minus 3, 0. Okay. Given the points that G is negative 1, 5, yeah, H is 2, 5, and I is 4, 1. Identify the fourth point that completes a parallelogram. So I'm going to go for this one. There are options, but I'm going to do this one here. So this is 1, 1. Okay. And here we go. Question 4 is, given the points J, 3, negative 1, K, 5, 3, and L, 1, 3, identify the fourth point that completes a parallelogram. So there's two options here. I could go here, or I could go here. I'm going to choose to go here this time. Okay. So that is that is 6 minus 1. Okay. Right, let's do the second round and then we'll just mark these like we did the last one as well. So, question 5. Given the points M is 0 minus 2, N is 2 minus 1, and O is 2 minus 6, identify the fourth point that completes the kite. So that will be here. So that's going to be 4 minus 2. Okay. Here, question 6 is, given the points P at 4, 5, yeah, Q at 6, 8, and R at 8, 5, identify the fourth point that completes a kite. Okay, so there's loads of options here. I'm going to go for here. Okay, because that will make a nice kite. But you could have anything along this line. Maybe I'll do a different one. Maybe I'll do, it's got to be on this line here. Here we go. That would still be a kite as well. Okay. So, yeah, that is the kite. There's one line of symmetry. My lines aren't the best. But so let's say, you could have just had any of these points though. So let's say that's 6 minus 5. That's what I'm going to go for this one. Okay, question 7. Given the points S, 1, negative 1, T, 5, negative 1, and U, 2, 5, identify the fourth point that completes a parallelogram. Okay, so I think I'll go for, that's got a slant here. We've got to make sure that it goes in the same way. 1, 2, 3, 4, 1, 2, 3, 4. Yeah, that'll be fine. So the coordinates at this point are 6, 5. Okay, and then question 8 is, given the points 3, 0, V is 3, 0, 4 is negative 1, 4, W is negative 1, 4, and X is 5, 4. Identify the fourth point that completes a parallelogram. Okay, so I'm going to go for 1, 2, 1, 2. So it's got to be here. So that is negative 3, 0. Okay, so let's get these marked. Okay, and let's see, maybe I might adjust these. Okay, so oh, here we go. Oh, here we go. The scenario answers are here. So there, 5. Got it. Okay, so here we are. Yep, so we did the same one there. Oh no, so I didn't expect people to write it down. I just expected the point to be plotted. Okay, yeah. This agrees. Yeah, this one agrees here. And yeah, so I've put the 2 X's there because you could have either one. So here we go. That one is fine. Right, and then question 5. Yeah, we've done the same thing here. We put all the options down here. We've put, yeah, there was 2 ways that you could have gone with this. So we've got those both marked there. And then, yeah, there was multiple ways you could have gone with this one as well. So I've wrote that on that. I actually am going to do a quick bit of editing on this because I don't like the way that I haven't left a space between here and here. I know it's very small, but it doesn't look nice. Right here, because there's options, I'm going to change this to A. In fact, a square, yeah, parallelogram. And here. I wonder why I didn't leave a space there last time. Okay, great. Right, that's those ones done. So just save that. And then here we go. And now we can move on to oh, another lovely topic. Right, okay. This topic is just about practicing the names of the shapes. You're going to see a lot of diagrams in functional skills maths, and you just need to know what they are. So this one is meant to be a cuboid. This one is a cone. This one is a cylinder. This one is a sphere. This one is a triangular prism. This shape, all sides are the same, it's a cube. This is a pyramid. This is a hemisphere. This is a trapezium prism. And this is a pentagonal prism. What a delight! That was 55. I feel foolish now for not squeezing these into the last one. Okay, right. Anyway, so let's get these marked. Where are we? Ah, damn it. Here we go. Okay, at 55, here we go. Yeah, cuboid or rectangular prism, yeah. Cone. Cylinder or circular prism. Sphere. Triangular prism. Cube. Pyramid. With the pyramid, sometimes you'd say square based or triangular based, but we can't tell with this one. Hemisphere, trapezium prism, and pentagonal prism. Okay. Right, next topic. This is a nice one as well. It's just a nice morning, isn't it? Right, 56. Connect 3D shapes with front, side, and plan elevations. Plan views, okay. What does the shape below? Does the shape below show the front, the side, or the plan elevation? So, I'm looking at, I think here, this shows the plan. This shows, I can see this shows the view from the top. I'll just quickly get my highlighter here with this one. Actually, no. One sec, I want to go back to pen. Let's just change this with the highlighter. Okay, right, so this one here, you can see we're looking, if we look at these ones here, okay, the plan is the view from above, so it's those. So this is plan. Okay. Does the shape below show the front, side, or plan elevation of the shape to the side? Okay. 1 second. Was that the words that I used before? Yeah. Does the shape below show the front, side, or plan elevation of the shape to the side? Yep, that's the plan. This one here is the side. So it's these ones. Okay, so if we looked at the side for that one, that's what we'd get. So that's side. Does the shape below show the front, below show the front, side, or plan elevation of the shape to the side? Okay, this is going to be the front. We can see here, it's these three, it's that, it's these two, it's that. So we don't see depth when we look at things, apparently, when we're looking at in talking about elevations. So, okay, right. Let's just do these. They only come in a set of 6, so we can get those done. So practice questions. Does the shape below show the front, side, or plan elevation of the shape to the side? Okay, so this is, to me, ooh, this actually could be the front or side. Front or side. Okay, you can see here this would be the front, and the side it would be the same. So we'll have to put both there. Okay, question 5. Does the shape below show the front, side or plan elevation of the shape to the side? We need this pincer thing here, so that's going to be from above. I can see that. That's the only way we're going to get that little pincer. So yeah, so 2, 2, full length, 3, yeah. So that's plan. And then question 6, does the shape below show the front, side or plan elevation of the shape to the side? And that has to be the plan again. I think if we look at it above, we've got 2 squares, 3 squares, 2 squares, 1 square. Okay, right. So here we go. Let's get this one marked. Okay. Oh, we had 3 more questions. Oh, let's just do the last 3 questions and we'll mark it all as one go for practice. Okay, so here we go. Draw the side elevation, okay? Oh. Draw the side elevation. Okay, that's fine. So we've got this, 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 and this. So it's going to be like this. Here we go. That's what we'd see from the side. We can draw in the squares as well if we want. It wouldn't matter either way which way you did it. Draw the front elevation of the shape. Okay, so we've got 3 squares here. Okay, and then we've got 2 squares. Then we've got 3. And then we've got 3 again. So here we go. That's the shape that we draw. Sorry, our shape's so bad. That's what we'll do. I'm going to draw each individual square. Okay. And then lastly, we've got here, draw the side elevation of the shape. Okay, so we've got the side is going to be 1. These ones here. And these ones here. Okay, so it's going to be 1, 3, 3. So it'll be like this: 1, 3, 3. Okay, so that will be the side elevation. Right. Okay, now let's go back to question 1 and we can get these marked. Here we go. So question 1. Okay, so plan. Excellent, we agree. Side, we agree. Front, we agree. Front or side, we agree. Plan, we agree. And plan, we agree. Then let's have a look at these diagrams. Yeah, 7 is in agreement. 8 is in 8 is in agreement as well, I believe. Yep. And 9 is also in agreement. Wonderful. Okay, right. On to the scenario questions for these ones. So here we go. These are a bit different. Don't look at the answers. Right, okay. So here we go. We've got a helicopter is looking for a tent from above. Draw a plan elevation of the tent to show what it would see. Oh, I don't have a full stop there. I think, let me just put that in. 1 second. Okay, not a biggie, but just something that we need. Okay, so it's going to be a rectangle like this. So we'll draw a rectangle because that's what it's going to see. That's all the triangle will look like from above. But we have to show the center line, which is a crease. So we just draw that in as well. So it's going to see a rectangle with a line down the middle. Okay. Right. An architect is making drawings of a house. Draw the front elevation of the house. So here's the house. So the front elevation is going to be a rectangle with this triangle on top. Okay. We don't see this dividing line. Okay. So we just see creases. Right. Question 3. I hope my mark scheme agrees with that. That was a bold claim there. Right. An architect is making drawings of a house. An architect is making drawings of a house, drawing the plan elevation of the house. So it means to say draw. Okay, so let me just quickly alter that. Here we go. Draw the plan elevation of the house. Right, so that's going to be, the plan is from above. So this is just going to be a rectangle. And then we've got a crease here where the roof starts. And we've got a crease for the point of the roof. Okay. So that's not perfect, but it'll do. Okay. Here we go. A helicopter tour is organised over the pyramids. If the pyramids have a square base, what will the view be? What will the plan view be? Okay, so it's going to be a square. And then we do see the creases. So we'll have the dot in the middle. And then we'll have a crease here, a crease here, a crease here, and a crease here. Right. Question 5. A cone is placed on the side of a road. Draw the side elevation of the cone. Okay, so a cone from the side just looks like a triangle. Okay, that's all we see. And here we go. Question 6. A diamond is the shape of 2 square-based pyramids placed together. Draw the side elevation of the shape. Okay, so we're going to have a triangle for the top, and then this will be a crease, so we will see that, and then we'll have a triangle at the bottom here. Okay, so there we go. Lovely. Right. Yeah, there we go. And that's 56 done. Right, let's get these ones marked. I'm nervous. Did I draw all the creases last time? This is my big question. Excellent, they're there. I can see them all. Okay, right. So, yeah, there we go. Question 1 done. Question. Oh. That's not a crease, so I don't think that should be there. But that's a difficult thing to fix. Right, I'm going to have to put a star there to come back for that, because I'm... One second, One second. Actually, it's not so difficult to fix. Page 368. I've got an idea. Page 368. Right, shape. Here we go. Actually, no, I don't want that shape. I want this shape. Okay, I want to make it white. No, I don't. I want to make it white like this. Okay, thank you. And then I'm just gonna put you here. Oh, that hasn't worked. Does that do the job? I think that works. Okay, excellent. Let's quickly group those images. Arrange, group. Okay, right, so back to the remarkable. Okay, that's fixed. Okay, answers. Okay, yep, so that is now done. So we agree with that. So we agreed with this one. We agreed with this one. We agreed with this one here. Yep, number 4 is correct. Number 5 is right. And number 6. Wonderful. Right. Okay. Let's move on to topic 57. So we are looking at missing angles. Okay, so question 1. So what we need to know about this is angles on a straight line add up to 180 degrees. So if one angle on a straight line measures 70 degrees, what is the measure of the missing angle? Okay, so here we go. So this one would be 110, because 180 minus 70, 110 degrees. This next one here is going to be, in a straight line, if two angles measure 80 degrees and 50 degrees, what is the measure of the missing angle? Okay, so again they make 180. So 80 add 50 equals 130. 180 take away 130 will be 50 degrees. So there we go. Right, question 3. If one angle on a straight line measures 120 degrees, what is the measure of the missing angle? Okay, so we're going to do 180 degrees minus 120, and that will equal 60 degrees. Okay. Question 4. We've got here, in a straight line, if three angles measure 5 degrees, 70 degrees and 90 degrees, what is the measure of the missing angle? So the box here represents a 90 degrees, 70 degrees. Okay, so we've got 90, add 70, add 5. So that makes 165 degrees. And then 180, take away 165, equals 15 degrees. So the missing angle should be 15 degrees. Question 5. If two angles on a straight line measure 110 degrees and 60 degrees, what is the measure of the missing angle? Okay, so we've got, that's we've got a mistake here. So that isn't 110 degrees, that says 120. So let's quickly fix that. What page is this? 274. So that should say 110. Okay. I know that this one's the wrong one because 60 add 120 already makes 180, so that angle wouldn't exist. So here we go. Here we go. Here I'll try. So okay. So we've got 60 add 110 is 170. 180 minus 170 is the missing angle. So here we go, that would be 10 degrees. Question 6. If two angles around a point measure 100 degrees and 120 degrees. Oh, right, so this says 110. Right, okay, well, fine. We're on the page. Okay, 100 degrees and 120 degrees. What would be the missing third angle? So, just say that's 110. 100 degrees. So the missing angle would be, well, we're going to do 100 add 120 equals 220. 220, well, 360 take away 220 will equal 140 degrees. Okay, so the missing angle is 140 degrees. Okay, let's do these ones. In a full rotation around a point, if three angles measure 30 degrees, 60 degrees and 90 degrees, square 60, 30, what is the measure of the missing angle? And it's kind of obvious from this diagram actually. So we've got 90 add 60 add 30 will equal 180 degrees. And then we're going to do 360 take away 180, which equals 180 degrees. So the missing angle, so this side here, it's the complete straight line, so that will be 180 degrees. Question 8. If one angle around a point measures 240 degrees, what is the measure of the missing angle? Okay, so here we go. It's going to be 240, and it's going to be 360 take away 240, and that will give us 120 degrees. And then question 9, we've got if four angles around a point measure 45 degrees, 90 degrees, 20 degrees, and 160 degrees, what is the measure of the missing angle? So we just need to add all of these together. So we've got 160, add 20, add 90, add 45. So 180, 270, 315. And then we do 360, take away 315. And that equals 45 degrees. Okay, so that's 45 degrees. Right, and I believe that's the last question. Okay. Right, so let's get these questions marked. Here we go. Right, so question 1, 110. Let's just underline that. Question 2 is 50 degrees. We agree. Question 3 is 60 degrees. We agree here. Question 4 is 15 degrees. Question 5 is 10 degrees. Question 6 is 140 degrees. Question 7 is 180 degrees. Question 8 is 120 degrees. Oh, it doesn't really matter. Question 9 is 45 degrees. Was there a question 10? No, there was once a question 10, but I got rid of it because I wanted to fit 3 questions on a page. And I don't think you lose out anything by not having the question 10. So let's get rid of that answer. we go. Right. Right. Let's enlarge this and start with the scenario questions. So here we go. A ladder leans on a wall. One side of the ladder makes an 80-degree angle with the ground. What is the angle on the other side of the ladder? Okay, so here's the diagram. This is the angle that we want to know. One side makes an 80-degree angle, so that will be this one. That's 80 degrees. So this is going to be the other side, so we're going to have 180 degrees minus 80, and that will be 100 degrees. Okay. Two roads meet at a T-junction. The angle they make on one side is 35 degrees. What is the angle they make on the other side? Okay, so if that's 35, this is a straight line because roads are generally parallel. Okay, so what we've got here is we're going to have 180 take away 35, and that will equal 145 degrees. Right, a guide rope is attached to the ground at a 45-degree angle. Okay, what angle does it make with the ground on the other side? Okay, so this bit here is our 45, so this is going to be 180 take away 45 degrees, and that will equal 135 degrees here. Right, question 4. Oh dear, I've been missing, there's just missing a space. It's not a big deal, but let's get that sorted. Where are these angle questions? Right, here we go. These ones are fine. What? Okay. And that one's already got its space. Great. Okay. So, at a street intersection, two roads form one angle of 80 degrees. What is the size of the other angle formed between the two roads? Okay, so I can see it on the diagram, so it's that one. So this is a straight line. So we've got 180 degrees, take away 80, and that will give us 100 degrees. Okay. Question 5, we've got here, a ramp is placed against a step. If the angle below the ramp with the floor is 20 degrees, what is the size of the angle above the ramp? Okay, so here's the one that's 20 degrees, and this is the one above the ramp, so they make a straight line. So we're going to be looking at 180 degrees, take away 20 degrees, and this will be 160 degrees. Okay, right. Question 6. At 2:30, the angle between the hands of a clock is 105 degrees. What is the size of the angle? What is the size of the other angle between the hands? Okay, so that's going to be 360 take away 105. Okay, and then that will be 255 degrees. Question here. Friends are sitting around a circular table. If each person occupies 72 degrees of the table, how many friends are there? Okay, so it's 360 degrees divided by 72. Okay, and that equals 5 friends. Okay. Question 8. Yolanda is drawing a flower with 7 petals. If each petal measures 50 degrees, will the petals make a complete circle? Okay, so 7 times 50 equals 350 degrees. No, they won't. Okay. Question 9. Joz is facing north and turns 35 degrees clockwise. Okay, so that's this bit here. How many more degrees must he turn before he is facing north again? So that's going to be, the full turn is 360. 360, take away the 35, will be 325 degrees. Okay, right. Let's mark this. Okay, so right, what have we got? First of all, I know, scenario. Okay, so we're looking at these ones here. We've got 100 degrees. Yeah. 143. Oh no, 1 second. So where's the question? That's meant to say 145. Let's edit that. 140. Here we go. Degrees. Here we have 135 degrees. Yep, that agrees. 100 degrees. Yep. 160 degrees for question 5. 255 degrees for question 6. Five friends. Yeah. No, 10 degrees left. Yeah. No, they won't. And then 325 degrees. Excellent, right. Okay, topic 58. Let me just have a... Sorry, one moment. Okay, so here we go. Let's enlarge this and get started with these. So angles in a triangle must equal 180 degrees and angles in a quadrilateral equal 360. Okay, so it's the same topic again really. So what we have here is in a triangle, if one angle measures 60 degrees and another measures 40 degrees, what is the measure of the missing angle? So here's the triangle that they're talking about. 60 check, 40 check, missing angle. So we'll do 40 add 60 equals 100. 180 take away 100 equals 80 degrees. Okay, question 2. In a quadrilateral, if 3 angles measure 70 degrees, 90 degrees, and 180 and 100 degrees, 100, 90, 70, yep. What is the measure of the missing angle? Okay, so we're going to have 100 plus 90 plus 70. So that equals 260 degrees. So we do 360 degrees, take away 260 degrees, and that is going to equal 100 degrees for the missing angle. Okay. Question 3. If 2 angles in a triangle measure 30 degrees and 80 degrees, what is the measure of the missing angle? Okay, so here we go. So we've got 30, tick, and 80, yep, they match. At 80 equals 110 degrees. 180 minus 110 equals 70 degrees. So the missing angle will be 70 degrees. Okay, question 4. In a quadrilateral, so 360 this time, if 3 angles measure 45 degrees, 45 degrees, and 80 degrees, what is the measure of the missing angle? Okay, so we've got 45, add 45, add 80. So 45 add 45 is 90, add the 80 is 170. So they make 170 degrees. 360 take away 170 equals 190 degrees. So there we go. The missing angle is 190 degrees. Right. Question 5. If in a triangle, if 2 angles measure 60 degrees and 70 degrees, what is the measure of the missing angle? Did we just have that question? No, it was 60 and 40 and 30 and 80. That's fine. Right, so 60 and 70. So we do 60 add 70 equals 130. 180 take away 130 equals 50 degrees. Okay. Question 6. In a quadrilateral, if one angle is 120 degrees, yep, and the 2 adjacent angles are 50 degrees and 70 degrees. Adjacent just means next to, so these are the 2 angles next to it. It doesn't actually really matter, but what is the size of the missing angle? So here we go. So we're going to do 70 add 50 add 120. 70 add 50 is 120, so these 3 add up together to give 240 degrees. So then we'll do 360 take away 240, and that will equal 120 degrees as well. So that angle was also 120. Right, here we go. Question 7. In a triangle, if one angle is 130 degrees and another angle is 20 degrees, what is the measure of the missing angle? Okay, so here we go, 130, yep, 20, yep. So we're going to do 130, add 20, equals 150. Okay, so 180, take away 150, will equal 130 degrees. No, what am I doing? It'll equal 30 degrees. 30 degrees, yes, not 130 degrees. Right, there we go. Right, question 8. In a quadrilateral, if 2 angles are 60 degrees and 80 degrees, what are the remaining angle? One second. If 2 angles are 60 degrees and 80 degrees, and the remaining angles are equal, what is their size? Okay, right. So let's find out what both of them are first. So we'll do 80 add 60 equals 140. 360 take 140 equals 220. Okay, so they both add to make 220, but they're both the same, so we can just divide this by 2 equals 110 degrees. Okay, right. Question 9. In a triangle, if 2 angles measure 45 degrees, what is the measure of the missing angle? I don't like that that's on a different line. Let's just change that. Here we go. What we can do actually is Shift Option 8. Yay, and I get the little degrees sign. Here we go. That looks much nicer. If in a triangle, if 2 angles measure 45 degrees, I'll call it an isosceles triangle because that's what it is. Oh, I haven't spelled isosceles correct. There you go. In an isosceles triangle, if two angles, it doesn't look like an isosceles triangle, but it is not drawn accurately. Classic maths phrase, isn't it? Right, so in a triangle, if two angles measure 45 degrees, what is the measure of the missing angle? Okay, so we're going to have 45 add 45 equals 90. Okay, so 180 degrees minus 90 equals 90 degrees. Okay, so it's actually a right angle triangle. Maybe this is. One second, let me just go back to Keynote. Let's just change this. Is it constraint? Yes, it's just because of the angle. This actually is a perfect isosceles triangle. Yeah, it's just because it's on its slant, it doesn't look like it. Wow, the power of illusion. Right, so yeah, that was the last of that one. So let's get these ones marked. Here we go. Go to half page. Right. So here we go. We've got 80 degrees here. 1 second. Yeah, there we go. So 80 degrees, that's correct for question 1. 100 degrees for question 2. 70 degrees for question 3. 190 degrees for question 4. Yeah. 50 degrees for question 5. 120 degrees for question 6. 30 degrees for question 7. 110 degrees for question 8. And 90 degrees for question 9. Okay, wonderful. Okay, scenario questions. Right. Here we go. Right. Question 1. So, in a spaceship there is a control panel with 4 identical screens shaped like quadrilaterals. If 3 angles in one screen measure 80 degrees, 90 degrees and 110 degrees, what is the measure of the 4th angle? Okay, so let me get my white pen and go here. So I reckon that we've got, this looks like the 110 degrees. This looks like the 90 degrees. And this looks like the 80 degrees. So we're trying to work out this one here. That's our missing one. But again, the whole principle is the same anyway. So let me 1 sec. Let's work this out. So what we get here is we've got 110 degrees plus 90 degrees plus 80 degrees equals 280. So then we've got 360, take away 280, and that is going to be 80 degrees. Okay, that's a lot of space to answer that I don't necessarily need, but that's all right. It's better than not having it. Emma is organising a treasure hunt. If you find an angle in a quadrilateral that matches with an angle in a triangle to equal 150 degrees, you win a prize. Sadiq finds an equilateral triangle and a square. Has he won a prize? Okay, so in a square, all angles are the same. So these are all 90 degrees. In an equilateral triangle, all angles are the same as well. So we can do 180 divided by 3, and that equals 60. Okay, so 360 divided by 4 equals 90, so that's the square. 1 second. So this is the triangle. Oh, that's a square. This is the triangle. This is the square. Okay, and then we can do 60 add 90, and that equals 150 degrees. So yes, if you find an angle in a quadrilateral that matches an angle in a triangle to equal 150 degrees, you win a prize. Sadiq finds an equilateral triangle and a square. Has he won a prize? Okay, is that clear? Emma is organising a treasure hunt. I don't think that is clear. Emma is organising a treasure hunt. Emma is organising. Right, I'm going to star this and come back to that because that needs a lot more thought, that question. Emma is organising a treasure hunt. If you find... Emma is organising a treasure hunt where you hunt for shapes. If you find a quadrilateral, and a triangle where their corners can be put together to equal 150 degrees, you win a prize. I think that's better. Emma is organising a treasure hunt where you hunt for shapes. If you find a quadrilateral and a triangle where their corners can be put together to equal 150 degrees, you win a prize. Sadiq finds an equilateral triangle and a square. Has he won a prize? Yeah, perfect. I prefer that. All right, question 3. Okay. At a playground, there is a climbing structure made to look like a row of houses. Each house has a roof made of an isosceles triangle where the top angle is 40 degrees. Okay, so this bit here is 40 degrees. Okay. And the other two angles are equal. Okay, so because they're isosceles. So if I've got that, one second, I'm just going to draw that out here. So if this is 40, okay, 180 take away 40 equals 140 degrees. 140 degrees divided by 2 equals 70 degrees. So these angles are 70. Okay, so that angle is 70, and that angle is 70, that angle is 70, that angle is 70. So all of these angles here at the bottom are 70. Okay, right. Each house has a roof of an isosceles triangle where the top angle is 40 and the other two angles are equal. If the triangle sits on rectangles, what is the angle of the gap where the roofs meet? Okay, so, and I've got this arrow here showing that. So this gap is going to be, so because these are rectangles, that means that this makes a straight line. Okay, so that's a straight line there. I can see that as well. So we're going to have 180. Well, so what we need to do is, this is a straight line. So the situation that we're looking at really, outside of this diagram, we're looking at this. So we've got here a straight line. We've got that there. We've got that there. This is 70. This is 70. So we need this angle here. 3 angles on a straight line. So we've got 180. Take away 70. Plus 70. Okay, so that's 180, take away 40, 140. So the missing angle will be 40 degrees. Okay, there we go. That looks a little bit like 400, so I'm going to change that. Yeah, 40 degrees. Right. John is building a John is building a stadium in the shape of an equilateral triangle. Okay, equilateral triangle means that all the corners are 60. 60. That's 60. This is 60. Okay. It has a trapezium-shaped seating section. Here we go. Where the angles are 100 degrees and 80 degrees. Okay, so the top two are 100 degrees, the bottom two are 80 degrees. John needs to work out the angle made between the seating area and the side wall. So this angle here. Right. Okay, so okay, so if this is an equilateral triangle, this bit will be an equilateral. Well, actually, oh, okay, this is easy. Okay, so what we've got here is we've got. I'm just going to redraw this situation here. So we've got this, like this. Okay, so we've got this is 60, this bit is 80, and this is the angle that we want. Okay, so what we're going to do is this is on a straight line. So if this is 80, this must be 100 degrees. Okay, so that's 100 degrees there. And then we've got two angles in the triangle here. So 100 add 60 equals 160. So then this is a triangle. So 180 take away 160 equals 20 degrees. Okay, there we go. So that is going to be 20 degrees. Question 5. Janet is making a 90-degree join for a shelf. She accidentally cut the join incorrectly. She wants to measure how far out she is. She knows that 3 of the angles for each piece of wood are 90 degrees, 90 degrees, and 138 degrees. How far off making a right angle is she? Okay, so these two look like they're the 90 degrees. Okay, this will be the 138 degrees. Okay, and this, I don't know why she didn't just measure this angle. Okay, so this is the angle that we need to know. Okay, so we're going to do 360, take away 90, add 138. Okay, so 90 add 90 is 180. 180 add 100, let me just get the calculator out. So we've got 180 add 138 equals 318. So we've got 360 take away 318 is going to be 42 degrees. Okay, so this angle is 42 degrees. So that means that this angle is also 42 degrees because it's the same join. Okay, so 42 degrees add 42 equals 84 degrees. Okay, she wanted to make a right angle. Right angles are 90 degrees. So 90 degrees take away 84 degrees equals 6 degrees. Okay, so she is 6 degrees off making her right angle. Okay, right. Question 6. Lisa wants to construct a mosaic artwork using triangular and quadrilateral shaped tiles. She wants to use equilateral tiles. What size does she need to make the 4 angles of the quadrilateral? Okay, so let's think about this here. So we've got that this bit here and this bit here. So these bits are going to be 60 degrees. They're 60 degrees, so that's this bit here. So that's 60, 60. And then we know that's 60 as well, and that's 60 as well. So we've got different things going on here. We've got, at the top, we can see we've basically got a straight line situation where this is 60 and this is 60. So this missing angle here is going to also be 60 because 60 add 60 add 60 makes 180. So we're going to want the top ones to be 60. Okay, now angles in a quadrilateral have to add up to 360. So we know that 2 of the angles are 60. We'll just write that down there, 60 and 60. Okay, that's two of them. So two of them are 60. So let's think about that here. Okay, so we've got here like this. So this angle's 60, this angle's 60 here. So together, 60 add 60 equals 120 degrees. Okay, and then we're going to do 360, take away 120 degrees, is 240 degrees. So the other two angles have to add up to 240 degrees. So we need to do 240 divided by 2 equals 120. Okay, so the other two angles here will be 120 and 120. Okay, so we've got 60, 60, 120, 120. Okay, there we go. Let me get rid of that. So they are our four angles of the shape. Right. Okay, question 7. At a museum, there is a symmetrical sculpture made of a triangle on top of a trapezium. The total angle where the triangle meets the trapezium is 110 degrees. Okay, so that is this thing here. So this angle here where the triangle meets the trapezium is 110 degrees. The sculpture makes a 70-degree angle with the floor. Okay, so that's this one here. How big is the angle at the top of the triangle? Okay, right. So if this is 70 degrees, this will be 110 degrees. Okay, it's symmetrical, so that means that this is also 110 degrees. Okay, and this whole thing here. Okay, right, so let's look at this this quadrilateral bit here. So if this is a symmetrical shape, and it's a four-sided shape, and this is 110 degrees, and this is 110 degrees, these two angles must be the same because it's symmetrical. So what we can do here is we do 110 add 110 equals 220 degrees. Then we can do 360, take away 220 degrees, will leave us with 140. So these two angles must make up 140. 140 divided by 2 equals 70. So this angle is 70 and this angle is 70. Now the whole angle from here to here is 110, but if we know that from here to here is 70, then this bit must be the remainder of what gets us to 110. So we'll do 110, take away 70, and get 40 degrees. So this bit would be 40 degrees. So, oh, that's still not the end. So that's 40 degrees. This bit's 40 degrees because it's symmetrical. So 40 add 40. So in the triangle, they have to make up to 180. So 180, take away the 40 add 40, is 180 take away 80. So that's 100 degrees. So the angle at the top of the triangle will be 100 degrees. Okay, I'll put that here as well. 100 degrees. Okay, right. Question 8. In a classroom, there is a display board with an equilateral triangle and rectangular artwork. If all the bases of the shape are parallel, what angles does the rectangle make when it touches the triangle? Okay, right, so it's equilateral, so that's 60, 60, 60. Okay, these are rectangles, so that's 90 degrees. Okay, if all the bases are parallel, that means up here, okay, this is going to be a symmetrical situation, okay, where it's got a line of symmetry here. I'm just looking at this bit here. So this is 60. Now these two angles have to be the same. So 180 take away 60 equals 120. 120 divided by 2 is 60. So these are both 60. So that's 60 there. And that's 60 here. Okay. This bit here will be a right angle. Okay. So if I look at that top triangle there, we've got 60. and we've got 90, which means I can now work out this third angle. So 60 add 90 equals 150 degrees. So that third angle is 180 take away 150, which equals 30 degrees. So this bit will be 30 degrees. And then we've kind of got a straight line situation here. So we know that we've got, I'll put that there. We've got a straight line situation going on here, where this angle is that angle there, 30, so that's 30. This angle in the middle is this bit, which is 90. Okay, and that means that we've got 90, we've got 30, and then this bit here will then 90 add, well, it's going to be 110 take away 90 add 30, 180 take away 90 add 30, which will be 180 take away 60, take away 120, which will equal 60. So this final angle here will be 60 degrees. So let's make that, so that one there is 30 and this one is 60. Okay, 30, so the answer here is 30 degrees and 60 degrees. Okay, so let's make that nice and clear, and then let's do the last two. Oh no, that was it. There was only 8 questions on that one, so that's nice. So we can get those marked and hopefully they'll be correct. Okay, and then let's see if we can get 59 done. If we got up to 60, that would be amazing. I'd be absolutely back on track. Okay, so 1 second. Here we go. There. Right, so question 1. Where are we? I was just thinking about 60 and I forgot what we're actually doing. Okay, so we are on 58 scenario. Okay, 80 degrees, excellent. 150 degrees, wonderful. 40 degrees, yeah. 20 degrees, yeah. 6 degrees, yeah. Question 6. What size does she need to make the 4 angles of the quadrilateral? Okay, so I need to update the mark scheme just to put all 4 angles there. So we've put 120 in the mark scheme, which does agree, but the question says the 4 angles, so let's update that. Where are we? Question 6. So 60 degrees, 60 degrees, 120 degrees, 120 degrees. Okay. Right, so there we go. Right, so that's fine. Okay, next one, we've got question 7 is 100 degrees. Yep, I feel like we earned that. Question 8, 30 degrees and 60 degrees. Wonderful, right. Okay. Question, topic 59. Okay, let's go here. Right. So, So identify the scale on a graph. Yep, practice questions. How many people are represented by each thin grid line? Okay, so we've got here, let's just enlarge this a little bit. We've got 1, 2, 3, 4, 5 thin grid lines. I felt like I could see that anyway, actually. 5 thin grid lines per thing. So that's, and each thing is 20 people. So 5 lines equals 20 people. So 1 line equals 4 people. Okay. How many people had the favourite colour yellow? Okay, so this looks to me like it reads, it lands, here we go, on this line here. 1, 2, 3. So it lands 3 up from 140. 3 up from 140 is, well, 140 plus 3 times 4. So that would be 152. Okay. Question 3. How many days are represented by one small square on the vertical axes? So we've got 1, 2, 3, 4, 5 squares. 5 squares equals 5,000. So 1 square equals 1,000. Okay, just underline that. So 1,000 days. Okay, question 4. How many years is represented by one small square on the horizontal axis? Okay, so again we've got 5 squares equals 10. So 5 squares equals 10. Okay, so 1 square equals 2 years. Okay, right, question 5. One small square one small square on the vertical axis represents how many degrees Fahrenheit? Okay, there's no question mark there, so I need to get that in. Here we go. Okay, so right, let's see. So we've got again 5 squares is 20. 5 squares equals 20 degrees F. So 1 square will equal 4 degrees F. Okay. And question 6. One small square on the horizontal axis represents how much of a meter? Okay, so 1 meter, 5 squares equals 1 meter. So 1 square will equal 1 divided by 5. 1 divided by 5, 0.2 meters. Okay, and that's the practice questions done for that topic. Okay, so let's get this over here. Here we go. So first one, 4 people. Yep. Oh, I've gone for 153. Yes, I actually do agree with that. But because it was slightly above the line, but I think because the diagram's so small, and I just made that mistake there whilst zooming in, I think I just need to say that 152 is also acceptable. because that wasn't an error in my answering, it was just an error in the question. Okay, because the diagram isn't quite clear enough. So here we go. 150. There we go. Okay, there we go. 153 people, 152 acceptable. I think a lot of people will be drawn to the main grid line. Okay, so next one we've got here, so that's fine. Where were we? 1,000 people per square. Oh no, this one's 1,000 days. Okay, so go back to that. 1,000. Yep. It was days, wasn't it? How many days? Days. Yep. There we go. 2 years per square. 2 years. Yep. 4 degrees Fahrenheit per square. 0.2 meters per square. Excellent. Right. So let's have a go at 59, and then I actually think we're going to stop there. I think, and then I'll just have 60 to 70 to do tomorrow. Okay. Right. So here we go. How many people? How many people had a favourite colour of green? Okay, so we need to work out the scale first. So again, it's 5 squares is 20. So here we go. I actually feel like I might need to edit this so we've got some more working out space. 5 square equal 20. 1 square equal 4. Colour of green. Okay. So here we go. Oh. So we've got here, this is halfway. So we've got 60 and then this is 64. Oh gosh. Let's see if I can make that smaller. So this line would be 64. This is 68. This would be 72. And then we've got halfway between here. So I say that's 74. Okay. So let's go back there. So I'm going to say 74. But in the mark scheme, I'll say that 73 to 75 is acceptable. How many people preferred green to red? Okay, so red is nice and easy. Red is 20, so 74 take away 20 is equal to 54. Okay. Question 3. How many days is 30 years? How many days is 30 years? Okay, so 30 years, go up to here, go across here, so it's how much was each square? Each square was 1,000, so this is going to be 11,000 days. Okay, right. Question 4. How many more years is 10,000 days than 5,000 days? I don't like that these are on different lines. That's a few things that I don't like about this. Okay, that's the first round. This is the second round. Okay. How many days? Oh. How many days are there in 30 years? How many more years is 10,000 days than 5,000 days? Okay, so that would be 5,000 days. Okay, so let's go back to, so it's 5,000 days more. So let's work that out, what that is in years. So if we go here, and that's going to be here. So 5 squares equals 10. 5 squares equal 10. So 1 square is 2. So it's 10 plus 14 years. Okay. Question 5. What was the average degree Fahrenheit for the tree that was 2.9 meters? Okay, right. Tree height versus average temperature. Right. This must be like where they live or something. So tree height, 2.9 meters. Here's the 2.9 meter tree, and it looks to me like that is just below this line. So if this is 5 squares, this is 5 squares makes 20, so 1 square equals 4. Okay, I think this is almost a whole square, but not quite. So I reckon this is a 3. So I reckon it's 103 degrees. Okay. So there we go, 103 degrees. And then, how much taller was the tallest tree compared to the shortest tree? Okay, so this is the tallest tree here, and that looks like it's 7 point, well, each little square is 0.2, but that's halfway through the last square, so that's 7.9 for the tallest tree, and the shortest tree lands nicely here, so that's 1.6. So that will be 9 take away 6 is 3. 6.3 meters in difference between the smallest tree and the tallest tree. Okay, so let's mark these, and then we are done for the morning. Well done for doing this on your Saturday morning. That will be really good. Well, I mean, here we go. Right. So up to question 1. 74 people, yeah. 54 people, yeah. 11,000, yeah. 14 years, yeah. 103, yeah. And 6.3. Perfect. Right, well, thank you very much for joining me. We did quite a lot there today. So there's just 10 topics left to do, 60 to 70, and hopefully I will get all of those done tomorrow. So, and then the book will be ready to be launched. And so I will put that in the process of the final publishing edit, and then it will be available to buy, and I'll put a link in the YouTube and on my website. Okay, wonderful. Right, well, thanks again, and see you tomorrow.